All right, so we want to continue on this example. Last time we had you moving at 15 feet per second. Now what we want to do is we want to put this together where you're starting, or 12.5 feet per second. We want to start at 15 feet per second, go in our circular turn that has a 5-foot radius, and end up at 10 feet per second. You might notice that that means if this is slowing down, we'll have some point in here where it's 12.5 feet per second, right? Slowing down uniformly. It won't be directly in the center. It'll be somewhere in between, but it won't be directly in the center. Actually, it'll probably be a little farther out this way. Okay, so we'll use that later. All we care about are the 10 and the 15 for this part. Okay, we'd like to figure out how fast it's slowing down. What is the tangential acceleration? If you go in this curve from 15 feet per second to 10 feet per second. So that means we're going to have to find the acceleration with the delta v over delta t, so that's v2 minus v1, 10 feet per second minus 15 feet per second over that time. Let's see. We need to find that time, so we can use the average velocity, which is just the distance traveled from here to here over the time. So let's highlight that. This D is green. This green line is D. So we're traveling over this distance, this curvy distance, as we try to fix these things, as we try to slow down. And then finally, see, we can figure this out. That's not too hard. T is what we're looking for. V bar we need something for. We're saying that you're slowing down uniformly though, so we can use the average velocity is v1 plus v2 over 2. So we'll go ahead and use that. Right? So how does that work? Well, v1 plus v2 over 2, that's 15 feet per second plus 10 feet per second over 2. And that is 12.5 feet per second. So we got that. That's pretty reasonable. So let's go on. Now we need to find D. Right. So V bar we said was 12.5 feet per second, and D is this quarter of a circle. So a circle is 2 pi r, 2 pi times 5 feet, divided by 4 because it's a quarter of a circle times t. 2 point. Okay, that's 2 pi times 5 divided by 4 is 5 over 2. That's 2.5 times pi. 2.5 times pi is probably a pretty ugly number. We'll go with 7.85 feet over the time. So we've got that. Now we have to figure out what that time is. So that's 7.85 feet over 12.5 feet per second, which is more than half, I guess, 0.628 seconds, right? Feet cancel, 1 over seconds becomes seconds, so 0.628 seconds. Okay, so now we've got this thing that we can bring the t into here with. So let's see, we've got Vf minus Vi, so that's 10 feet per second minus 15 feet per second. So this thing's going to be negative because we're slowing down. And then we have a 0.628 seconds on the bottom. It's minus 5 divided by 0.628, and that's feet per second, second squared. Okay, so this is going to be larger than 5, 0.628, that's gives these minus 7.96 feet per second squared. Okay, so that means, you know, we've got a reasonable slowing down for this amount of time. Let's see, so with this, how do we do that? Well, we start with our definition of acceleration. This is our AT. To find that, we need to figure out the time. Well, we can do that with average velocity, and we can figure out the average velocity by taking these two guys and dividing by 2, summing those and dividing by 2. It's just the average, right? That's all we need. Halfway between 10 and 15 is 12.5 feet per second. That gives us a time of 0.628 seconds. Plug that back in and we get minus 7.96 feet per second squared, about minus 8 feet per second squared. All right, so that was an example with the tangential acceleration. Finally, we'll talk about putting all these things together as one acceleration. Bye now.